Hello everyone, I am Karthik from ITA section and my roll number is 230, and today on concept video my topic is about introduction of reduced instruction set. Let us know what is reduced instruction sets and its applications, advantages. Let us see. Reduced instruction set computer. It is also called as RISC. RISC is a microprocessor that is designed to perform a smaller number of types of computer instructions so that it can operate at higher speed, perform more millions of instructions per second, or it is also known as MIPS. And since each instruction type that a computer must perform requires additional transistors and circuitry, a larger list or set of computer instructions tends to make the microprocessor more complicated and slower in operation. So this is a basic definition, that is microprocessor that is designed to perform a smaller number of types of computer instructions. That is known as reduced instruction set computer. Let us see some more information about RISC in further slides. John Koch of IBM Research in Yorktown, New York originated the RISC concept in 1974 by proving that about 20% of instructions in a computer did 80% of the work. The first computer to benefit from the discovery was IBM's PC or XT in 1980. Later, IBM's RISC system uh, per 6000 made use of this idea. The term itself, RISC, is credited to David Patterson, a teacher at the University of California in Berkeley. The concept was used in Sun Microsystem SPRC microprocessors and led to the founding of what is now MIPS Technologies, part of Silicon Graphics. A number of current microchips now use the RISC concept. This is about some information about RISC, and John Cook of IBM Research in Yorktown, New York, originated the RISC concept. Let us see some more information in further slides. The RISC concept has led to a more thoughtful design of microprocessor. Among design considerations are how well an instructions can be mapped to the clock speed of the microprocessor. Ideally, an instructions can be performed in one clock cycle. How simply an architecture is required and how much work can be done by the microchip itself without resorting to micro software help. Besides performance improvement, some advantages of RISC and related design improvements are: a new microprocessor can be developed and tested more quickly if one of its aims is to be less complicated. Microsystems and application programmers who use the microprocessor instructions will find it easier to develop a configured smaller instruction set. These two are the advantages of RISC and related design improvements. One is about a new microprocessor can be developed and tested more quickly if one of its aims is to be less complicated. And another one is operating system and application programmers who use the microprocessor will find it easier to develop code with a smaller instruction set. So this is about the information in this slide. Let us see some more information in further slides. The simplicity of RISC allows more freedom to choose how to use the space on a microprocessor. Higher level language compilers produce more efficient code than the formerly because they have always tended to use the smaller set of instructions to be found in a RISC computer. So in this slide, it is saying that higher level language compilers produce more efficient code than the smaller level language compilers. The reason is they have always tended to use the smaller set of instructions to be found in a RISC computer, which helps faster compilation. Let us see some more information. Uh, this is a RISC chip, UltraSpark. Use of RISC architectures. RISC architectures are now used across a range of platforms, from smartphones and tablets computers to some of the world's fastest supercomputers such as Fugaku, the fastest on the top 500 list as the list of November 2020, and Summit Syra and Sunway Twilight and next three on that list. These are some of the world's fastest supercomputers. They are Fugaku and Summit and Syra and Sunway Twilight. Uh, RISC architectures are one of the major architecture which are used in all platforms like smartphones, tablets, computers, laptops, etc. Low-end and mobile systems. By the beginning of the 21st century, the majority of low-end and mobile systems relied on RISC architectures. Examples include the ARM architecture dominates the market for low power and low cost embedded systems. It is used in a number of systems such as most Android-based systems, the Apple iPhone and iPad, Microsoft Windows Phone, former Windows Mobile, RAM devices, uh, Nintendo Game Boy Advance, DS, 3DS, and Switch, Raspberry Pi, etc. The ARM architecture dominates the market from lower power and low-cost embedded systems, which are typically from 200 to 1800 megahertz. According to in 2014, it is used in a number of systems such as Android devices, Apple iPhones and iPads, Microsoft Windows, like that. It is used across all the mobile companies, etc. Let us see some more information for the slides. Desktop and laptop computers. IBM's Power PC architecture was used in Apple's Macintosh computers from 1994 when they began a switch from a Motorola 68,000 family processors to 2005 when they transitioned to Intel x86 processor. Apple uses self-designed processors based on the ARM architecture for its lineup of desktop and laptop computers. Since its transition from Intel processors, and the first such computers were released in November 2020. Workstation servers and supercomputers. MIPs by Silicon Graphics ceased making MIPs-based systems in 2006. SPARC, known as Spark by Oracle, previously Sun Microsystems and Fujitsu. IBM's IBM Power Instruction Set Architecture, Power PC, and Power ISA were and are used in many of IBM supercomputers, mid-range servers, and workstations. Hewlett-Packard PARISC, also known as HPPA, discontinued at the end of 2008. Here, the conclusion is the key operational concept of RISC computer is that each instruction performs only one function. Example, copy a value from memory to a register. The RISC computer usually has many, like 16 or 32 bits, high speed, generally purpose registers with a load or store architecture, in which the code for the register instructions for performing arithmetic enters are separate from the instructions that grant access to the main memory of the computer. The design of the CPU allows RISC computers few simple addressing modes. This is about RISC computers. This is about the conclusion, and thank you. Thank you all.